We are given the two vectors A vector and B vector, and we have to determine if these two vectors are orthogonal, parallel, or neither. So we see that two vectors are orthogonal when their dot product is 0. That is, when A dot B and this equals 0, we see that the two vectors are orthogonal. And we see that the two vectors are parallel if one vector can be written as a scalar multiple of another vector. That is, if we can write A equals to lambda B, or if we can write B equals some t times of A, where lambda and t are some scalars, then we see that these two vectors are parallel. The shortest way to determine the parallel vectors are we find the ratio of the corresponding components, and if the ratio is the same, we then say that the two vectors are parallel. Ratio of the components are equal to each other. Okay, so let's see how to determine this orthogonal, parallel, or neither. First, I'm going to do the dot product. So let me do the dot product, that is A dot B. And this equals, we have to find the multiples of the corresponding components. So we have negative 8 for I and 6 for G. So we have to multiply these two, that is negative 8 times 6. And then we add with the other multiple, that is 12 with negative 9. That is for J component, that is 12 times of negative 9, and then we add with this the multiple of k component, that is k component is 4, and here it is negative 3, so we do 4 times of negative 3. Let's check if it is giving us 0. This is negative 48, and this is negative 108. 4 times the negative 3 is negative 12, and so this gives negative 168. This is negative 168, and clearly this is not equal to 0. So since we did not get A dot B equal to 0, we can say that this is not orthogonal. And this means this could be either parallel or neither. So now let's determine if it is parallel. So for this, I'm going to take the corresponding components and find the ratio of the corresponding components. So first, let me write the A vector in component form. So A vector is negative 8, 12, and 4. This is the component form of A vector. Also, let me write the component form of B vector, that is 6, negative 9, and negative 3. And let's find the ratio of the corresponding components. So here we take this x component is negative 8, and this is 6 for B vector. So we find the ratio, that is negative 8 by 6, and this we have to check if this is equal to the other ratio of of this y component, that is 12 by negative 9. So this is 12 by negative 9, and we should also check if this equals the last component, that is 4 by negative 3. Now let's check this. We can simplify this. This is 4 times 2. This is 3 times 2. And here also this is 4 times 3 is 12. And this is 3 times negative 3 times 3 is negative 9. So we can see that the ratio finally reduces to negative 4 thirds. And here also we have negative 4 thirds. And here also we have negative 4 thirds. So we check that the ratio of the corresponding components are equal to each other, which means the vectors A vector and B vector are parallel. A and B vectors are parallel. S2 part B. So here we have the vectors A vector equals 3i minus j plus 3k, and b vector equals 5i plus 9j minus 2k. So first let me do the dot product, that is a dot b, and this equals I have to find the product of the corresponding components. So I do 3 times of 5 plus the j component is negative 1 here, and it is 9 here. So I multiply these two, plus the k component is 3, multiply with the k component is negative 2 here. So let's check this. This is 3 times 5 is 15, and negative 1 times positive 9 is negative 9, and this is 3 times negative 2 is negative 6. So this gives 15 minus negative 9, negative 6 is negative 15. So 15 minus 15 equals 0. So clearly we see that a dot b equals 0, and this means these two vectors, that is a vector and b vector, are orthogonal to each other. We now do question 2. So here we have to determine the angle between the two vectors a vector and b vector. So the formula that we are going to use is cos theta, where theta is the angle between the two vectors a vector and b vector, and this is given by a dot b, that is the dot product of a vector and b vector, divided by the magnitude of a vector times the magnitude of b vector. So we have to find this a value. Let's do that. First, I'm going to find the dot product of a vector and b vector. So this equals, I have to multiply and add the corresponding components. So here I have the I component is 4 for a vector, and the I component of b vector is 2. So I multiply these two, plus I do the multiplication of j components, that is negative 3 for a vector. But here we don't have j components, so we can put this as 0, plus for k vector it is 1, times for the k component is negative 1 here. So let's simplify this, and this gives 4 times 2 is 8, and this is 0. 1 times negative 1 is negative 1. So 8 minus 1 is 7. So we have determined a dot b equals 7. Now let's find the magnitudes of a vector and b vector. We can find the magnitudes as like this. We have to take the square root of the sum of the components. So the for the a vector we have the components of 4, so we take the 4 square, plus the j component is negative 3, so we take its square, and the k component is 1, so we do 1 square. So this equals 4 square is 16, plus negative 3 square is 9, plus 1 square is 1, and so this gives 9 plus 1 is 10. 10 plus 16 is 26. So we get square root of 26. And in the same way, let's find the magnitude of b vector. So we take the sum of the squares of the components and we take its square root. So I put the square root. The I component is 2, so we put 2 square. J component we don't have, so we can put this as 0, plus k component is negative 1, so we put negative 1 square. And so this gives 2 square is 4, plus negative 1 square is 1. So we get square root of 5. Now we can plug it into the cos theta formula. So let's do that. So therefore we say that cos theta, and this equals a dot b, which is 7, divided by the magnitude of a and magnitude of b. The magnitude of a is square root of 26, and the magnitude of b is square root of 5. And so we can plug this into the calculator, and from this we can also find the value of the theta. So since we have to determine the theta, we say that it is equal to cos inverse of this ratio, that is 7 over under the root of 26 and under the root of 5. So first we plug this expression into the calculator and then find its cos inverse value. And when we do that, we get the approximate value of theta, and this is approximately equal to 52.12, and this is in degrees. So this is the angle between the two vectors A vector and B vector.